Question 7 of the DEB mock in 2017 was a function question, and it said the height of a diver after jumping off a platform into a diving pool is given by a formula h of t. So h of t is equal to minus 5t squared plus 5t plus 10. And your h is the height of the diver above the waterline, and t is time. Right, so they want to know, part 1, find the height of the diving platform. So what you want to know is, what height were they when they jumped? So when they jumped, time was 0, so you, in other words, are working at h of 0. So h of 0, you're plugging in 0 everywhere there's a t. So when you do that, you get 0 plus 10. So the height of the diving board was 10 meters. Okay, part 2 asks you what's the length of time before the diver enters the water. Okay, so enters the water will mean that the height was 0. Right, so you're letting 0 equal to your function. So in terms of that, you can use the minus b formula, or in terms of this one, it's a very easy one to solve. So you go minus 5 by your 10, which gives you 50. Get the factors of 50, which are 5 and 10. Rewrite this as 4 parts. So your two middle parts, your plus 10t and your minus 510, 5t should equal to your 5t here. Right? Look at your first two terms, see what they've got in common. So they've got minus 5t in common. Take it out, and you're left with t minus 2. Rewrite that bracket. What are you missing? So you're missing a minus 5. Regroup your brackets. So you've got a minus 5t minus 5 from here and here, right? And then your second bracket, which is t minus 2, being equal to 0. So in other words, minus 5t minus 5 is 0. So 5t is minus 5. T is equal to minus 1. Or your t minus 2 is equal to 0, so t is equal to 2. In terms of correct answers, you cannot have negative time, so you disregard the t equals minus 1.
Hello?
Part B, it asks you to find dh dt. Right, so in other words, differentiate. So you write down your function, which is h of t, and then you're differentiating it. So you're bringing forward the powers of your t's, multiplying and reducing the power. So minus 5t squared becomes minus 10t. Plus 5t just becomes plus 5, and our 10 vanishes. So that's finding your dh dt, which you should be able to do with no bother. And then the next part, it says, find the rate of change of height at the instant that the diver enters the water. The rate of change of height is basically your h dash of t. Right, so h dash of t you worked out a minute ago was minus 10t plus 5. They enter the water, we had worked out in the previous part that it was equal to at 2 seconds. So you're getting h dash at 2 seconds. So you're going minus 10 times 2, which gives you minus 20, plus 5. So you're getting minus 15 meters per second. So basically the person is diving downwards at a speed of 15 meters per second when they enter the water. Part C, they ask you to find the length of time it takes for the diver to reach the maximum height above the waterline of a diving pool. Right, so it's saying maximum. So maximum, the brainwashing we want you to do, means you're using calculus. So you differentiate, let your differentiated function equal to 0, solve it, and then plug your answers into the original function again. So for this diving board one, our differentiated function h dash of t is equal to minus 10t plus 5. We let that equal to 0, so you go minus 10t plus 5 equals 0. Move stuff around, so you're getting 5 is equal to 10t. So your t is equal to 5 divided by 10. So your t is equal to a half. Right? You are then going to plug the half back into the original. So instead of writing down t's in the original, you are going to plug in a half. So when you plug that in, you get minus 5 over 4 plus 5 over 2 plus 10. Plug that into your calculator and you will get the maximum height. Okay, so this part is the answer for finding the maximum height. Part D, it says the diver performs a different dive in a competition. She reaches a maximum height of 0.75 meters above the diving platform after half a second. So after 1 second, she's at the same height again as her initial dive. The height of the diver above the water after 2 seconds is given by your formula g of t. Right? Find two expressions for the position of the diver in terms of a and b, and hence find the values of a and b. So our GT formula is AT squared and BT in 10. If you differentiate that, so her change, how much she's changing, it's G dash of T, which is 2AT plus B. Right? Okay, we want to find the maximum. It says she reaches her maximum height. So G dash of T is equal to 0, right? So we're just checking that. So when we check that, you get 0 plus A, 0 equals A and B, which is what you'd expect. Right? You are told that after 1 second, she is the same height as she was in her initial dive. So her height at 1 second was equal to A times 1 squared and B times 1 and 10. So tidy that up, you're getting A and B is equal to 0. Right? And the final bit, it is saying that she reaches a maximum of a height of 0.75 meters above the diving position after 5 seconds. So you have the diving board was at 10 meters, so she's now at 10.75 is equal to A, and your time is 0.5, B 0.5 and 10. So your two formulas that you will use are this one and this one, and you're going to solve them as simultaneous equations. Okay, I didn't have a calculator, so I haven't done that, but you are using that and solving as simultaneous equations. It is a normal eliminate simultaneous equations. Okay, so in terms of it, you'd have A and B is equal to 0, and you'd have 0.5 squared is 0.25, I think, A, and 0.5 B, and 10 is equal to 10.75. And you continue that and solve them. Okay, just not going to do it now.